Hello and welcome everyone. So this will be sort of a session where we'll not discuss the usual tech stuff that we usually do. So usually we discuss about the technical details and we go in depth. So today's session is dedicated, as I said, this is a long due session where I said that I'll be talking about generative AI in general and we'll take LLMs in particular. So again, I would love to start with questions. If you people have questions, so straight away shoot them, and then we can start from there, and then we'll go a little bit deeper also into these LLMs. This will be a generic session, not on the architecture details and how do we train, and maybe we'll touch some of the aspects, but more or less it will be a generic session. Any questions on generative AI and how does it work or something like that?
अस्सलाम वालेकुम सर
Yes.
सर ये सेम क्वेश्चन है मेरा कि अगर हमें कोई एलएलएम ट्रेन करना होगा सो
Mm-hmm.
व्हाट स्पेसिफिकेशंस वी नीड यानी व्हाट हार्डवेयर एंड दिस सॉफ्टवेयर्स वी डू हैव सो वी कैन at least
Mm-hmm.
not a big LLM but even a small 170 100 billion parameters wala so
100 billion
what
is a
would be
lot, yes, yes. I'll tell you the hardware specifications. Usually, it depends on the parameters that you have, okay? It depends on the parameters. Okay, I'll have this question and I'll answer this question. And first, we'll start about a bit about what generative AI is, and then afterwards, maybe we'll have questions. But keep this discussion engaging, ask as many questions as possible, and this will be a generic session. It might help you a lot because you might be using Gen AI tools, and then you should have a right context what to use them for, because many people have this notion that they can be used for this that, and then sometimes it gives nonsensical answers and then we claim that this tool is not working good. So if I talk about Gen AI, okay, let me just shift the screen because I won't write much things. So if I talk about generative AI, so what is this generation doing? Okay, so what are we generating basically? So the point here is that humans do generate data. So it is humans, okay, who generally generate data. Let's suppose if you speak, you generate data, and other devices also generate data. Let's suppose you capture photos by using the cameras and you have sensors. There are a lot of tools, but humans guide these tools and then they generate this data, generate the data. That's the point. So but now what is the meaning of generative AI? So we want something that can be generated without, let's suppose, having that equipment. Let me talk about the image. If you see image, okay, I need a camera or something for that. Either I can do it by camera or I can have an artist who can just draw an image, and maybe some other means can be there. So what we want is we actually want machines to do that. We actually want machines to generate those images, because you know, if you go into a little bit of detail, so if you see an image, it is just pixels, bunch of pixels, okay. So can we somehow have those pixels arranged in a certain fashion which will make sense to a human? Okay, if you suppose want to generate an image of a cat, image of a dog, image of some human being, okay, because the task now is to find the pixel values and arrange them in a certain way so that it makes sense to other humans, it makes sense to the people who are seeing it, and they should say this is a face. Okay, that's the task of generation. Now the generative AI basically it generates new content including text, images, audio, video. Based on the pattern, it learns from the data. Okay, it has a data and it learns patterns from that data, and then it tries to generate the data from what's called a same distribution. Okay, we have talked a bit about distributions. So data is coming from some underlying distribution. So what these Gen AI algorithms try to do is they try to mimic that distribution. They try to find those patterns from that distribution. If you have a data, okay, you have data, and then they analyze this data and they see these different patterns. They try to figure out the patterns and try to come up with the same pattern. Okay, try to come up with the same things, so, and we'll slowly formulate towards it. So this is in a broader sense what generative AI means. That is, you don't have physical equipments right now. You don't have a camera by which you can take a photograph, or you don't have a human speaking. So what will happen is it will be machines who will now generate the data, and each generation task is different. Generating language is different, generating image is different, generating audio is different. So they work on different principles, and there are a lot of algorithms and a lot of architectures that came along the way by this in this generative AI domain. If you see, it started with very basic things and then came up with generative adversarial networks, and then we have the diffusion models, and after we had transformer networks, and now they took the whole world by storm. Okay, and there were a lot of things that the transformer architecture can do. Okay, that is a bit about this what generative AI means. Generative AI is just generating new types of data, and I am saying it new. Why? Because it should somehow mix and match the previous data, whatever the pattern there was. It should not just have the sample which already is there. Then it is just sampling problem. Let's suppose you gave generative AI some data, and it is just showing up the sample that was already in the data. Okay, that is not generation. That is just sampling. But generation basically means that thing did not exist. That thing did not exist within your data. So let me show you an example where I got interested into the generative AI. Okay, give me a second. I'll bring up that website up. So if you see, there is a website which is called as, I think, thesepeopledon'texist.com. If I just type it, these people do not exist. So that is this person does not exist.com. So if you see this image, so this person does not exist in the world, but you can see the face. Okay, and you can see pretty much all the details in there. Okay, it looks a realistic picture if you see it. Okay, if I just refresh this again, and it will pop up a new picture, and in reality these people do not exist. It is not that it is just having the bunch of data and it is sampling from that and it is showing it. No, it is actually generating these samples. Okay, maybe it has generated those samples and kept it somewhere. Now for the website purpose it is just showing them up, but all these people, they do not exist. Okay, this is where I got sort of interested into this generative AI. And I think this is based on generative adversarial networks, and we might maybe speak about their architecture and stuff. And now we have even in the Meta also, in let's suppose Claude, and in all of these platforms which give services to the people, they have this image generation part also. So also they do generate text. Okay, so I showed you this. I hope that you guys can relate to, and you know the problem of generation. Sometimes we get confused that generation sometimes basically might mean that it is just sampling. It is not just sampling. What is it doing is, it is trying to come up with new samples rather, not having the existing samples in the data. So you will give it some data and it won't just sample an data point from the data. Rather, what will it do is, it will try to see the distribution, analyze the distribution, and try to remember the distribution. And after that it will generate a new sample from the distribution. Okay, let me speak some things about distribution. We'll see that in probability also, but here I'll for the people who don't know what distribution is, let's suppose if I take height of people. Okay, if I take height of people, so height of people, you see that it will range a lot. So you will see that height, let's suppose, starts from 0.5 meters. Say this is 0.5 meters, and let's suppose some 10 million people are in the range of 0.5 meters, and then let's suppose 0.6 meter and something like that. Let's suppose the max height is 1.7 meter, let's say. Okay, so these are the different values that will be for the height. Let's call that h. Okay, h will be the height of the person, and height of person may vary from 0.5 meters to 1.7 meters. Okay, so if this is the case, so what we'll do is, so we might see that if you see, let's suppose if you have total, let's suppose 1 billion of the people, let's suppose 100 people, we'll just maybe 100 people. So you might see that, let's say some 50 people have this much height. I should not say 50, let's suppose some 10 people, some 12 people have this height. So we'll basically distribute. Okay, we'll see how is the height distributed. So how many people have this, how much percentage of people have this, and usually what comes up is like this. Okay, let's suppose this is the mean height. Okay, so this is mean height. Okay, and this is, let's suppose, the least height 0.5, and this is the max height 1.7 meters. Okay, and here we have the count of the people. So if you see something like this, so you will see that most of the people will fall into this average height. Okay, so this is one of the type of distribution. So we call this a normal distribution, which is symmetrical distribution. So by distribution I mean that you have certain values. Okay, so now how is the population? So this is usually called as population statistics. So how is the population distributed now? So what amount of population, what percentage of population takes this value, this value? If you look it around, if you look for the whole population, then if you arrange them in a certain order, let's suppose in here we arrange them from 0.5 to 1.7 height. Okay, this was the height. So here we had, on this axis we had the height. Now here we had, let's suppose, the number of people. So if you see in that aspect, so we had the total number of the height of the people, and then we see how much. So this density basically shows that how much people you have there. So this is called as a distribution. Similar will be for the words also. So if you let's suppose have English words. Okay, so if I write all the English words that do exist in the dictionary there. And then if I collect all the text documents, so I have words, okay, then I'll collect corpus. So corpus basically means a lot of text documents will be there. Then I can find the distribution of words. I can say, okay, this the word exists in, let's suppose, all the documents and this and that. I can find the distribution. I can find distribution from this corpus. As in the first example, we had heights of the people, and then we were saying that we'll find the distribution of heights. How is this height distributed? Okay, if I take a normal person, so what is the chance that he'll be in that? And this is a whole dealt-in probability and stats. We'll see them in detail, but I just wanted to give you a sort of glance into what I mean by distribution when I say a distribution. So if you take all the words from the English language, okay, and then if you take a lot of data, a lot of corpus, a lot of documents from the internet, and they'll follow a specific distribution, they'll follow some distribution, they'll be distributed somehow. That will, let's suppose if you only have 100 documents, so you can easily say that this word the exists in these many documents, this word exists in these many documents, and then you can come up with a distribution. Okay, so this is some sort of like I'll say minuscule version of what a distribution is intuitively, and we'll go in detail in while studying probability and stats. We'll see what distributions actually mean. So can I assume that now you at least have some clarity of what distributions are? Okay, particularly for the people who are in undergrad, so you might not have heard about these terms. Asif and Arshan might be there, Bomber Sergeant. So you people at least got an idea what distribution is. So distribution is nothing but basically you have certain values. So how are these values distributed? Okay, how are these values taken? Okay, as in the height, the height is from 0.5 to, let's suppose, 1.7, and it's a continuous range of values. Now, how do people take these values makes it a distribution. Similarly, in the context of natural language, you have words. Basically, it's called as vocabulary. So in natural language, it's called a vocabulary. So in the vocabulary, you have this vocabulary size, and then in the documents, what is the distribution? How are these words distributed in the documents? So that's called the distribution for these words. Okay, so what I'm saying is that these whatever networks you call them, or models you call them, they try to learn this distribution. They try to learn this underlying distribution. Okay, this is just for the height of the people. So once they learn this distribution, what will they do is, now they'll sample a point from here. So they'll pick a point from here and they'll show it to the people. But this distribution is learned from the sample data. Whatever data you have, this distribution is learned, and then you just sample the thing from that distribution and show it to the people. And similarly for this image also, if you ask me what is the distribution, so we'll see this basically is distribution of pixels. Distribution of pixels. How are these pixels distributed? Okay, now if I just have to create an image which is 28 cross 28 image, so that means it has 784 pixels. Okay, I have to generate each pixel here. So I have to generate this, each pixel has to be generated, and then I have to arrange them in a certain order also. Okay, that makes the search space very huge. Okay, how to search this? If you see it as a combinatorial problem, so it makes the space huge. So each of these 784 values have to be filled. Let's suppose, and then if you see RGB values, and then it has to take colors. So basically now what it tries to do, it tries to learn the distribution of each pixel. It'll take a pixel from a distribution which it has learned from data. Okay, and then it will put them together. Basically it is trying to learn distribution and giving some once it's asked to generate a new thing, it is basically generating a new sample from that distribution. Okay, and this distribution right now is 784 dimensional. So in height, that distribution was one dimensional because we are just sampling height. So here it was 784 dimensional. It has to basically generate 784 in that space. It has to navigate the space and generate a sample. Okay, so this is how they do it. So this is called as because they are learning the distribution, and in particular in these LLMs. Okay, so this is one way of learning, and there are other rule-based learnings, but I will restrict our discussion on this. Where they learn a distribution, and by distribution I mean they try to find a pattern. Once they found the pattern, and when asked to generate something new, so they'll just have this distribution at the place, and then they'll just give the sample from the distribution. Any questions on the distribution? Now we'll have this was the sort of heavy part. Okay, because we have not covered probability and stuff. That I try to keep my language very flexed so that you people do understand it. Okay, and this is how generative AI works mostly. If you see these generative adversarial networks, if you see these variational autoencoders, if you see diffusion models, if you see the transformer models, mostly that's how they try to learn the distribution from the data, from the large corpus. That's why they are data hungry. They require a lot of data in order to find those patterns. Is it all right? Can I move forward? Okay. And now we'll see what these LLMs are. Okay, now coming to the core part, what these LLMs are. As you know, I would want to define it what these are, large language models or whatever. So people are now thinking that they are just extension of what's called as n-gram models. Okay, n-gram models. And what are these n-gram models? So if I talk about these n-gram models, okay, let's speak about bigram model. Bigram model. So let's suppose if I show you a lot of data. So what we can do is, in that data there will be a lot of sentences. There will be sentence. Let's suppose cat sat on the mat. On the mat. Okay, what these bigram models basically are. So if I, let's suppose, give you this cat, okay, and then we'll see which word follows this cat. Okay, which word follows this cat, how much probability is there for sat, how much probability is there for on the mat, and let's suppose we have a vocabulary size. So what we'll have vocabulary, and we'll have a lot of words. Let's call them now. I'll generalize this thing. So I'll generalize it. So let's suppose I have this. I have word w1 till wn words in my vocabulary. So basically my dictionary contains n words, let's suppose. So I am trying to explain what a bigram model is and how does it work. So I have words from w1 to wn. So what I can do is, I'll say if I have this word wn, okay, so which word has the highest probability of coming, because I have huge corpus, I can count the frequencies, I can count the frequency of words, I can count the pairs. So w1 w2, okay, w1 w3, w1 w1 even, okay, and w1 w4 and so on till w1 wn. So I can count the frequency as all of these things. I can count frequency. By frequency I mean how many times do they coexist in every document. Let's suppose I have all the documents in the world. So if I somehow come up with, if this is a w1 word, okay, and what is the frequency that this w1 is followed of w2, okay. So if I have a large corpus, let's suppose this is 100 times, okay, and let's suppose this is some 2000 times, this is some 40 times, this is some 50 times, accordingly this is some 10,000 times, something like that. So from this we can convert it into probability. So are you understanding this, what I am saying? Okay, can you understand this? So what I am saying is, if we have a word w1 and then we have the vocabulary also. So I want to see, because I am restricting myself to the bigram models, I am saying that what I'll do is I'll search the whole documents and I'll see how many times does this word, does these two words occur together. This w1 w2, w1 w2, this is w1 w1, and then w1 w3, something like that. Okay, so I'll check all the frequencies and these frequencies can be converted into the probabilities. So what I can do is I can make a diagram like this: w1 w2 till wn, okay, and then w1 w2 till wn, and here I'll have the probability scores. So here I'll have probabilities. If you go like this, so I'll have probabilities. So let's suppose this w1 w2, the probability is 0.1, the probability is 0.01, and the probability is 0.5, 0.05, something like that. But now you know about the probabilities that all of these should sum up to 1. Okay, so basically from the occurrences I will convert it into probability. Okay, let's suppose this occurred some 1000 times in the whole document, this occurred some 10,000 times, something like this, and they occurred together. I'm saying this is 10,000 and this is 1000 times, so I decrease the probability. So if you see this, so from this I have the probability. Now what I can do is, so if I have word w1, so I can look into this probability distribution and I can say that, okay, so this word is w1, then now what I can do is, with 0.1 probability I'll pick up this word, with 0.01 probability I'll pick up this word. Okay, I can pick up, and I'll pick up w1 and then I'll sample from this. Basically that's called as picking up from the distribution. So I'll pick up the word, let's suppose that came up w3, and now I have w3. So corresponding to w3 I also again have the same column, no sorry, same row of probabilities. So again I'll say sample from that. From w3 I'll, let's suppose, sample wk. Okay, I have wk over here now. So from this I'll have probabilities also mentioned over here from the documents. And after this w1 wk, and once I see that, I'll again pick up some with the probability, because each will have some probability assigned to that, and we'll sample that thing. And let's suppose we got some word w dash. Okay, this is how we'll generate this sentence. Is it clear? Is it clear how a bigram model will work? So we'll have w1 to wn words, and what we'll do is we'll count the frequency of their occurrences. We'll see how many of times they occur together. Okay, once we have the count, so along this row we can convert them into probability. A simplest way of converting into probabilities is sum all of these together, and let's suppose it was 1000, here it was 10,000. So then divide it by all the sums. Then you sum this whole thing first and then divide each entry so that you convert them into probabilities. Okay, once you convert them into probabilities, then randomly initially you will start your sentence. You will start your sentence with something, or maybe you have a start token also. So you will say, this is my start token. How many times is this word? Okay, which word is the starting word most of the times? You can just sample that, and after that, what you can do is you can follow this. You can just see the row, corresponding row, and according to the probabilities, pick up those words, and you can complete the sentence together. Okay, I hope that this makes sense to you. And this is what is called as a bigram model. And similarly, this can be seen for n-grams also. So we'll make an n-gram, basically we'll have n minus one thing, and then we'll predict the nth token based on what is the n minus one. And this is the simplest probabilistic approach. Once we go this, we'll code this. So I'm promising you people that we'll code it. Okay, once we go to the deep learning part, we'll code that. I'll show you that how to, basically we'll make this at least bigram model, we'll make it, and I'll show you that it does perform, it does show you some results. Okay, so I might have a notebook with me also where I can just show you, I won't explain the code, I'll just show you the notebook. Whatever steps I showed you, I'll show you those. Give me a second or so. Okay, so, but I won't explain the code. Let me just create a new notebook. I'll write it bigram model. So this I'll explain in detail once we go to the deep learning part, once we go to the language model parts. So we'll go in detail. So is the code window visible? Is it visible?
Yeah, yes.
Yes, it is visible. So I'll show you these things. So let's suppose I'll import this matplotlib is seaborn. Yes, everything is there. So what I can do is I can generate a corpus. So let's consider these documents. Okay, so these are my documents, some words, a and powerful, a problem is creative data, and I have just created some junk data. Consider this as my corpus. So this is my whole list of documents, okay, which I was speaking about. Now there are a lot of words. So what I need to do is I need to tokenize this. So what is the meaning of tokenize? I'll take each word, I'll see how many words are there. So this is what tokenize, I'm separating out. I'm separating out basically each of the words so that I tokenize the data. I'll show you the tokenization also. So if you see this, so this is tokenized data. There is a word and, powerful, AI, problems, creativity. These are all the words. Okay, I basically took all the sentences. I did word level tokenization. So I separated out all the words, and then what I can do is I can create bigrams. Okay, so I can create bigrams. So let's suppose I'll create bigrams. So if you see this, so a and they exist 25 times together. And powerful, they exist 20 times together. Powerful and AI, they exist 10 times. Okay, similarly you can see for all the value, you can see that we have a whole dictionary of these values. Beautiful, is, and programming came 8 times, and future and a came 9 times. So I'm just keeping the count. Okay, so once I have this count, I can show you the matrix also, but it makes no sense. I can also print the matrix because in the code that I had written, I think long way back. So if you see this, this is the matrix. A and they exist together 8 times. A and AI exist 15 times. A and exist 25 times. So this is the count, and this is a huge matrix. So usually we have 32 by 32. That is our vocabulary size is 32. We have only 32 words. We can have more. This is just a mock-up data. So now after we have this, so what we have to do is now we'll calculate the probabilities. We'll convert them into probabilities. Okay. So this is how to convert these bigrams into probabilities. So if I show you now, this is the probability. A with and has probability. Like A will be followed by and has probability of 0.09. Okay, A with applications has probability of 0.03. Similarly, A with innovation has this probability, and similarly you can go through all of these. I just computed the probability of each word corresponding to this. Now let's suppose I'll write a generate function. By generate, I'll generate the sample. So in there I'll start with a random thing. So that's why you see this import random. Okay, so what I do here is import random and generate this. So once I generate, and then I'll just pick up the choices from the random and I'll generate the sentence. This will be the generate sentences. So if you see this, I applications, Python, beautiful, I love innovation, I love I learning language, something like that. It looks gibberish, but because the corpus size is less. Okay, and what it is doing is it's seeing this I, and then it has to sample the next word. So it is sampling applications. Once application is sampled, it will sample the next word. It is sampling Python. If I run it again, because it's random, it should change. Okay. So you can see this I, science, future, solution, and create, and this is a bigram model. So you saw that we got a corpus, and the first step was we tokenized the data. We took each of the word set, that's called as word level tokenization. Now we have character level tokenization. We have different types of tokenization. How do you separate out these words? And we have in byte level tokenizations also. And after we have that, then in bigram model, what we usually do is we'll see the occurrence of these bigrams together. How, let's suppose we have a word, is it followed by some other word? So what's the frequency? Those frequencies are converted into probabilities and then randomly generate the first word. And after, once we have that word, we slowly generate the other words based on what was happening previously. I hope that this bigram model is clear. Is it clear?
सर ये भी easy लग रहा है.
Okay, beautiful. That it, and there is no magic. There is no magic in these. We'll see these language models. So now language models are n-gram models on steroids. Okay, and they have done a lot of architectural change, this and that, and that's how they generate these things. And there they have attention, they have do this, do that, and we'll see all of these, and we'll start from the bigram models. So now what I told you is that if you consider this, let me just hide this code window. Okay, so now if you see these large language models as just as n-gram models, so they just are can be viewed as an extension, but there are architecture changes and there are different training methods and they are given more capabilities. But underneath the hood, it is doing this. It is basically trying to see what is called as context. It is seeing, let's suppose, past tokens. So they are called tokens usually. So whatever I call as a word, they are called tokens. That's why it's called tokenization. You break them into tokens. So it is seeing the previous context. It is seeing the previous context. And based on the previous context, it is generating the new token, the next token, and they are called as auto-regressive models. Okay, auto-regressive. Usually, whatever you have these ChatGPT, Llama, and Claude, all of these are auto-regressive models. What's the meaning of auto-regressive? Because they take into consideration what happened previously. Okay, let's suppose the first thing it generated was C, and then after seeing C, it generated A, then T. Okay, then space. Whatever happened previously, it will generate that, and then space, then sat, then on, then a, then mat, and then let's suppose it will stop. Let's suppose to generate this on, it will take whole of this into picture. This is called as context. Okay, you might have seen in news articles that ChatGPT supports this much context length. Okay, context length basically means how many tokens can it attend to, how many tokens can it keep in, let's suppose, I should not use this word, but how many tokens can it keep in the memory. Okay, this is called as context. So context is what came before it, and once it generated this on, now the new thing became like this. So based on this, it generated this a, based on this, it generated this mat, as we saw in the bigram models. Okay, so I hope this is clear. Is it clear? Is it clear? Now they have these branches. Okay, now how do you generate? There are different techniques of generation. So different techniques of generation. Okay, we won't go in detail. There is something called as greedy approach. There is something called as beam search. There are a lot of search methods. How do you basically, because it does not generate only one thing. Now once you have the sample, which thing to pick now becomes a question. Because if I just say left and, okay, what is the usual things here? Let's suppose the words can be right, left and right. People usually use, let's suppose it has a probability of 0.1 or maybe I think more 0.2. Left and center. Center also will have probability, some probability, 0. Let's suppose 18, something like that. And there will be a lot of words. Now which words select and put it here? That is how do we write different algorithms like greedy search, like I said beam search. Okay, and they'll select this word and put it here. And it won't happen at word level, it will happen basically at token level, and token cannot be a word, token may be a word less than a word. As I said, the different methods of tokenization are there. So let's suppose this word is high probability. If you choose the highest probability word, so what will happen is you are using greedy approach. So whichever word has the highest probability, once it sees this context and these are the vocabulary words, and you are choosing the highest probability word, that's called as greedy search. You are becoming greedy and taking that, and it does not let model get more creative. Okay, and sometimes what you have beam search also. So it basically creates a lot of beams. So you have left and then there is a lot of possibilities which words to select. Okay, so let's suppose it will have top 4 beams. They are called usually n beams. So from here it will again have a lot of possibilities, and from here it will again have a lot of possibilities. Okay, so once it has the possibility, and then we see, let's say after 2 steps, we're saying after 2 steps, whichever branch has the maximum probability, I'll generate those words. Okay, usually, and this is how beam search works. Like I am dumbing it down a lot, but I think you got the idea. So now you have this and you're keeping 4 beams alive. You are saying these four words I am taking, and after that there are different beams again, and then you're computing the probability at, let's suppose, step 2. Okay, so as it becomes more creative, this is how we sample from there, and these are generation modes. In which mode do you want to generate? So I just explained two. One is greedy, and then there are top case sampling, or there are a lot of things that people do in this. So if you see language model, it's nothing but n-gram model on steroids. Many people will disagree with me. No, this is not just n-gram model. It is not just, but you can maybe think it is an n-gram model, because you have n-1 tokens and you are generating nth token based on what is there in n-1. Okay, so that's how it does. But as we did with the bigram model, it is totally different with how these large language models like GPT and Llama, Claude do it. So they do it separately because they have their own what's called as architecture, and then they use, some people use self attention, and they use different types of attention also. Okay, is it clear so far? Now, what's it good for? Okay, what's it good for? The question becomes, so what is it good for? The good, it is good for distribution things. So whatever, if you have a distribution, okay, let's suppose language has a distribution, it has a clear distribution. That's why you will never see GPT or these large language models, they making a grammatical mistake. Why? Because there is a pattern in the language, there is a particular distribution, there is a pattern in the language. Okay, it captures that pattern. Okay, so the main problem comes with the content. There are two things, content and style. Okay, it captures the style in a great way. It is great at capturing style. Okay, but this content I am not sure about. Okay, how much that it can capture the content. Let's suppose if somebody can speak eloquently, but his content is total rubbish. Okay, that's what these language models should be seen as. They are really good at capturing style. Why? Because capturing style is a distribution. Okay, but content is not a distribution. Why do they get these facts wrong? Because facts at an instance, it's not a distribution. Okay, let's suppose we'll have different facts. Facts like what is the radius of sun, what is the radius of earth, they don't come from a distribution. Okay, they have facts, they're called instance level things. They have an instance. Let's suppose who is the president of United States, who is the prime minister of India. If it is in data, it probably try to replicate it, but it sometimes may get these facts wrong. If you see a mathematical problem, that is not a distribution problem, that is a factual problem. Rather, there is a whole procedure for that. Okay, so what is it good at? It is good at generating these distributions. It's good at mimicking those distributions. Okay, in that, one thing comes is copying style. So it can write beautifully. Maybe whatever content it is, maybe that does not have some intrinsic value. If you have to tell it to make a mistake, you have to give it prompt. Speak like let's suppose a person who speaks in broken English. Then it will give those things. Otherwise, it won't make a grammatical mistake. Why? Because it has learned the pattern. Okay, there's a difference between a formal language and an informal language. Okay, if you see formal language like Python, C++, or other language, so they have an interpreter. Okay, the interpreter is that because you can create a parse tree, and even C, they have a compiler, so you can check these because there are these semantic rules and everything is there, and there is some validity. But if you see this formal language, you don't have an interpreter. Okay, but basically the whole interpreter is the whole world. However you put the things, whole world, you can interpret in any way possible. Okay, that's why it's very hard to come up with the grammar first and then with the language. So rather what happens is language comes first, then grammar comes spontaneously. And in the computer language, it's reverse. You come with the grammar first. You say these are the rules, and after that you make a language. Okay, and once you give that, okay, now many people confuse it with that they have capability of basically reasoning a lot of things. They ask them questions. Okay, and many people have shown that it does not possess reasoning capabilities. Not just shown, it is a fact now. It does not have, because people, what they see is when they see some eloquence in the speech, they confuse it with the reasoning, and it's very hard to distinguish between is somebody reasoning or is he saying something from the rote memory. Let's suppose if I ask you a question, and that's a problem with these exams also. So when you go for these IIT, JEE, NEET coachings, so what they basically teach you there is patterns of the questions. They don't tell you to reason. Okay, they're showing you this is the pattern of the question, this is the formulation to solve it. You apply this formula, you will get this answer and fill in this thing. Okay, so now it is very hard to distinguish between a person who actually reasoned and came up with the answer and the person who just followed the step, who just did the rote memory and just came up with the answer. It's very hard to tell the difference between reasoning and what looks like reasoning, and because reasoning is usually from first principles. Okay, you should first take a step and then learn a different step and then infer something from there, infer something from that. But these language models do not do that. Okay, they generate these things, and I showed you this, and after that, let's suppose they'll give you some things. Any questions till now? I at least getting a bigger picture of how language models work. It's looking like I am talking to myself only. You should also ask me questions, or you divert the conversations. Otherwise, whatever comes to my head, I'll speak that.
सर,
Yes.
सर जो हम या इससे चैट जीपीटी से अगर हम रिसर्च पेपर लिख लेंगे
Yes.
तो फिर वो नोवेल ही होगा ना सर?
It will be, no, that's what I'm saying, it will be novel in style, so style is good. देखो स्टाइल इसमें बहुत बढ़िया हो सकता है, स्टाइल विल बी गुड, बट द कंटेंट इज द प्रॉब्लम. इट कैन जनरेट एनी gibberish, it can generate the things which may look, it may give sense, but the content is totally nonsensical. Okay, sometimes it generates sentences because it puts them in the right way. Now the interpreter, you are not interpreter, is there is no restriction how it can generate, because we have no rules for these languages how to interpret. As I said that formal languages, they do have a particular procedure how to check are they syntactically correct, are they semantically correct. And now with the informal language, with the natural language, the problem is that the whole world is an interpreter. So you want to interpret, you can interpret it. That's why sometimes you will see GPT give a brilliant answer, but the problem is it actually gave a brilliant style, and the content came out to be brilliant. But sometimes it just generates something rubbish, and it gives something, and we feel like, oh, probably this is factual, but it's what it's trying to do. It's just mimicking the language. Okay, so second thing that you can see it is basically trying to simulate the things. You can see it as a simulation machine. If you see a human, let me make a difference between this. If you see a human, we have a persistent memory, and let's suppose we are speaking right now. Whatever I spoke, I also have those things in my head, and if you can refer to that, I'll let's suppose I'll answer accordingly, and will fit the situation. But what these language models are, you can think them. Let's say you give one prompt, okay, and they generate the things right there. So if you want to go back again, probably you won't be able to access it. Okay, let me show you a simple analogy. So I'll go to chat GPT, and I'll maybe, okay, let me go to chat GPT. I'll show you something amazing. At least it should look amazing to many of you. What I want to do is I'll show you how different they do the work from us normal humans. And let me bring up the code window. No, sorry, so I should have not brought a Chrome window is there. So yes,
Chrome window is not visible.
can you see it?
No, yeah, yes, sir.
Let's play a game with GPT. Okay, so I'll explain you the game, and then what I can do is, let's suppose you might have heard about this game. You have to think about some object, and now I'll guess that object, but I'll ask you a question. Let's suppose if you thought about say pen. Okay, if you thought about this pen, I'll say you, okay, think about an object. You'll think about no, then I'll query you, and I'll just give yes no answers. You just give me yes no. I'll tell you, okay, tell me, is it used by humans? You can say yes. Is it used by animals? You can say no. Okay, I'll query you this, and I'll basically decrease my search space till I get to the right answer. I'll say, is it a pen? So if it was a pen, you'll say yes. Is it a, let's suppose, is it a dog? No. Let's say, is it a food? So I'll just ask you yes no, because now you have the thing in the mind. You have the object that I asked you. Keep an object in your mind, and then I'll ask you yes no questions until I get the answer. How many of you understood the game? The game is that you'll have to think of an object, and then you will have to ask yes no questions until it basically gets the right answer. Is the setting of the game clear? Is it clear? Somebody speak, I cannot see the screen.
Yes, sir, it's clear.
Yes. So I can say, I can play the same game with GPT. Okay, I'll play the same game. I'll say, let's play a game. Let us play a game in which you have to select an object, and I will ask yes/no questions. I'll ask questions where you will answer no or yes, and then I will accordingly guess the object, something like this. Okay, I hope that it picks up. Okay, so it sounds fun. I have picked an object, so it has picked an object, and go ahead, ask you a question. Okay, so I'll ask it a question. I'll ask it, let's suppose the question is it used by humans? Is it used by humans? I'm now talking about the object that it has thought in the memory. Is it used by humans? It's saying yes, it is. Is it a living thing? It is saying no, it is not a living thing. Basically it means it is used by humans and it is a living thing. Is it edible? So can we eat it? Something like that. I am making spelling mistakes. No, it is not edible. So can we? Does it move? Does it move? Something like this. Okay, they're saying no, it does not move. And let's suppose now I'll say okay, I don't know. Please tell me the answer. Please tell me the answer. Okay. The object I picked is chair. Okay. Now it showed this. Okay. If it was sort of saying the right thing, so I'll just change this prompt. So I said, does it move? It said no. Okay. So I'll say, can people sit on it? Okay. Can people? Because I know now it is chair. Can people sit on it? And I'll again send it. And it is saying yes. So I'll again prompt it. Okay. Is it made up of wood? Yes. But usually plastic, chair can be plastic also. So is I'm right now what I'm trying to do is I'm trying to go outside the chair so that it does not generate the chair. Once I ask it the response, it should not stick with the chair. I am giving it a response so that it changed the answer. So is its color yellow? Something like this. No. And does it have an engine? So does it have legs? Does it have legs? It does have. What is the object?
5. You can put, does it have 5 legs?
Okay, let's. Does it have 5 legs? No. Does it have 4 legs? Does it have 4 legs? No. Now it deviated. Now it deviated because now chair has 4 legs. Okay. Now I'll ask it. Okay. What is the object? What is the object? Now you can see it here. Does it have 4 legs? It said no, and it said chair. Let me again change this prompt. Is it bigger? Is it bigger than house? Okay. Let me just give it a prompt so that it deviates many times so that it changes the object. Is it bigger than house? Is it bigger than a chair? Now I'll prompt it accordingly. Is it bigger than a chair? Yes. Is it kept outside the house? This conversation is becoming long. It's kept outside the house. Is it a chair? No, it is not a chair. You can see this. Okay, what is it? What is the object? The object I was thinking is a picnic table. You see? How many of you are able to see it? Now it is basically nothing keeping in memory. It is not keeping in the memory. So whatever prompt I am giving based on previously, it is generating the thing. Okay, so how many of you understood this thing? So the point here is what I try to do is I try to give it a prompt, and if it was thinking upfront, if it had that memory part, okay, it kept it in the memory, and then it basically will just keep it on chair. It will keep chair, and then it will never change the answer. Now what is it doing basically is once I give a prompt, it is giving some specification. So now it is settling the things according to the specification. Okay, here I said, is it a chair? It said no, it is not a chair. Okay, what is the object then? The object I was thinking of picnic table, but initially you saw that before some prompts it was saying it is a chair. So now how humans work and the GPT work is entirely different. Okay, these basically just generate things based on what was previously done. If I would have asked you, you would have never changed the answer. You would have given me specific, is it a chair? You would have said yes, it is a chair. I was thinking of the chair. But here you saw that initially it said that yes, I was thinking of the chair, and once I changed the prompt and I made it deviate from the chair. Okay, it thought of some other object. Okay, basically that means that it is doing what is called as impromptu. It is just thinking at that time, not thinking. Basically, it is just generating whatever is the previous context. Based on that, it is generating the thing. It is not keeping those things in the view as humans do it. Okay, so this is one of the examples. So where I showed you that you can just see these tree of thoughts what they have, and then it just picks one of them. Okay, as you saw that initially it said chair and then suddenly it changed the tree, and you should not basically ask such questions which are what's called as out of distribution, which do not follow a distribution, like the factual questions, or if there is an algorithm, let's suppose, and it needs computation to perform, should not ask the ChatGPT to do it. So what is it better for then? I said it is better for copying style. So if you have a style, you can copy the style. Any questions on this? Any questions?
Sir,
What?
Yes, go ahead. I think can you raise your hand so that I can call out names? Yes, Arshan, go ahead.
What about logical reasoning? Like
It does not do it. It does not do it. It does not reason it. Rather, what it does is, as I showed you, from this point I try to tell you that it is not basically reasoning anything. So it is seeing the previous context, and based on that, it is generating the next token. Okay, same for the coding. So what you basically do when you ask it for a prompt, generate me a code which adds the number. So there are a lot of documentations written on internet when web was scrapped. So here, then in the comments, it saw that. So it saw that when people write add two numbers, okay, and then they put a comment or something, and then they write the program def and something like this. So when you gave this prompt, okay, this was a prompt, and it will generate this thing what followed it. Okay, it basically is trying to just generate the next token. It is not seeing your logic. So that's why usually people say that they don't understand what they speak. So usually it because on the internet there will be lot of corpuses which have in the code this line, okay, add a number. So what I'll do is it will pick up from the documentation and God knows from where. So it will basically take this as a prompt and generate next tokens as this. That is sometimes it makes such a small mistake. If you ask it to do something, it makes a small. It sometimes misses. Let's suppose variable name. It sometimes gives a variable name hello, and it will sometimes use some other triple LO, something like this. It makes these minuscule mistakes, but the structure is right. But if you see, it makes these minute mistakes. So in the code, it does not generate the logic. So rather what it does is, whatever context you gave, it will generate it auto-regressively. It will generate the next token, and after that, generate next token without keeping in the view that there is a logic, there is some constraints. As you said, does it look for the logic? It does not look for the logic. So if you ask it a novel problem, which let's suppose is nowhere in the internet, then it should be able to solve that. It should have been, it should have reasoned from the first principles. It should have said, okay, they want me to do this, so first step should be this, then should be this, then should be this. Okay, but it does not do like that. So what it basically does is, without constraints, whatever is the previous context, seeing the context, and it generates the next word. And if you see, these code languages are rather easy to replicate. So if your assignment is if ChatGPT is able to do an assignment, that means it is no novel problem. So if you are doing a novel problem, that ChatGPT will struggle because it will have no instance. Okay, no instance of this. So if I again, why will it struggle? So if I, let's suppose, tell you how to multiply two numbers. Okay, so I'll show a generic method. I'll give you, let's suppose, two-digit numbers first. Two-digit numbers. Okay, then I'll show you, okay, this is a generic technique. You can apply it to 3-digit. I'll say 12 into 14. If you have to multiply it, this is the mechanism. Take this 4 and multiply it with these two. So you'll get it like this. Then put a cross over here, then write it and multiply this number with these two. So and then add them together. Okay. Oops. This will be 8, 6, and this will be 1. And this is how I showed you this. So I showed you a mechanism to do this. But if you somehow gave this to ChatGPT, so you will have to tell it two-digit thing is done like this. Then also three-digit product is done like this. So you have to show it each instance because it's not learning at all. It is trying to find the pattern. It's not trying to see the logical reason. Okay, the reason is this. If you multiply these things together, it will happen like this. It is not trying to do that. It is rather find the pattern. That's why if you ask it, if you convince it, if you say what is 9 plus 2, let's suppose it will give the right answer, 9 plus 2, because there will be a lot of corpus on the internet where 9 multiplied by 2 will be given as 18. So if you try, no, my wife said it is 19. So it will say yes, it is 19. The question is, it's basically conversing with you. It is not rather doing the logical reasoning. Okay, you see the difference. Many people have they put nonsensical prompts on this. They are showing, oh look, ChatGPT is making a mistake. It is not it is not doing that. So that shows the ignorance that you don't know the fact that how is it generating the thing. So if you are forcing it to do something, it will, because it is trained on whatever you context you give. It is generate the next word based on that. Okay, so one example of that is, Caesar cipher. People have written papers on this. So if I have A, B, C, D, okay, if I want to do a Caesar cipher, that means just substitute it. So A can be replaced by, let's suppose, A plus 2. That means replace it with C. Okay, A plus 2 basically means, so if A to Z are given some numbers like 1 to 26. Okay, so if I say a plus 2, so this will be a scheme, not a plus 2, maybe letter plus 2. So okay, whatever letter appears, just go 2 forward and replace that with the letter. So a will be replaced with C, B with D, and C with E, something like this. So this is called as substitution. You substitute these words, and these are called as ciphertext. And I hope everybody knows this. If you are from CS background, so you know this. You have a plain text and you can substitute the other words, and this is what is and you have a letter. So you can make a 4-year-old kid, you can ask them, okay, if I have word hello, okay, if you do the substitution of plus 2, just make these words plus 2. Let's suppose H, G, H, I, so G, H, I and J, so H should be replaced with J, so this will be replaced by J, and then E plus 2 is, so C, A, B, C, D, E and F, so this will be replaced by F. So J, K, L, M, N, so this will be replaced by N and N. M, N, O, P, Q, this will be replaced by P, Q. So this is my ciphertext. So this was my plain thing, and now this is my cipher. Okay, if I now give, let's suppose any kid, I'll say, okay, I'm saying smart. Can you just make it the ciphertext? Or can you, let's suppose if I give a ciphertext, the coding scheme used is plus 2. Okay, he can easily decode code, and this is very, because it hardly took me a minute or so to explain you people. It will hardly take me a couple of minutes to teach it to a 4-year, 5-year kid, and he'll be able to precisely do it. But when GPT was given this, it terribly failed. Okay, and it was say, okay, this is how these things are, but because it learns the distribution, okay, this actually is not a distribution, and now it actually performed good on what's called as row 13. If you get plus 13, that is A plus 13, so whatever is the 13th character after A, pick up that. Why is it performing good on row 13, not on rotation 2, rotation 5 or rotation 26, something like that? Why is it not performing good on these but on this? Because Linux actually supports this. So when people were writing this Caesar cipher, they somehow, many of the people wrote this rotation 13, and now they have a lot of data for this row 13. Okay, and from the internet it learned the pattern and it was performing good on row 13, but on this row 2, row 3, it was not performing good at all. Okay, there are papers written on this. Okay, now this tells you one more thing, that it learns the distribution rather than reasoning. It does not reason at all. Okay, whatever is the context given, the next word is predicted based on the context. So now if you see any post given by any person and you asked it for a weather, it will see basically a distribution. It does not give the factual information. You see, if you see ChatGPT saying 9 into 3 is somewhat, let's suppose 34, all right, no problem. Why? Because maybe there is data and something happened, and from all that context it gave this, it generated this 34, because it's not trained to do the logical calculations or do the planning part of the things. Now people came up with agentic behavior. Now if you give it a task which is mathematical, so it will invoke an agent which will perform mathematical calculations, and if you give it a task specific, which specific tools are used, so LLM will internally invoke some other tool. Okay, for the calculation it will generate, it will invoke calculators. For the let's suppose doing of image generation, it will invoke some other model. But in turn, if you see, these things are not even expected because of the architecture and because of what we expect from language models, and we try, because it is trying to see the distribution, and the better point is that it should be used for idea generation. Okay, idea generation. Why this? Because idea generation requires a lot of knowledge. Okay, it requires a lot of breadth knowledge. Maybe in-depth knowledge is a separate thing, but if you have a lot of breadth knowledge, and then you can come up with good ideas. And but it should never be used as a verifier. Okay, verifier, it does not perform good. Why? Because for verification you need to have constraints of logic and reasoning. So here you need constraints. So let's suppose if you want to build something, just take ideas from it, because it will have a lot of domain knowledge, different domains. And one way of seeing the large language models is compressed version of internet. So it's compressed version. So people might be thinking that, oh, there are so many parameters, we have billions of parameters. You should be thankful that there are only billions of parameters. Think of the data that is on the internet. It is huge. And then we have a basically lossy compression. There is a lot of loss in compression, but you only got, let's suppose, 400 billion parameter model, and it is performing really nice. So what it is trying to do is compressing all that knowledge together and then giving us the answer. So it is a smaller version. So if you compare it with the human, probably human will have a lot more parameters, maybe hundreds of more in the magnitude of 100x of parameters than just the state-of-the-art GPT that we might have, a state-of-the-art large language model that we have. You can think it as a compressed version of whatever was the internet, whatever data it was given, it tried to compress that into its weights and bias, into those parameters Okay, and then I'm saying is because now it has the vast knowledge, it knows things about, it does not know basically, it just have the patterns, it has patterns about biology, it has patterns about mathematics, it has patterns about astronomy, everything. So if you want to work on something, so the better could be you could ask it to generate things, the idea generation, and then you can be a discriminator, you can be a verifier. Okay, this thing is wrong, pick up this thing is right, do this. Now people tell me it will reason, probably some other models will reason, but this language model, if you don't come up with new architectural chains and you still try to increase the parameter and expect that they will come near to artificial intelligence and they will do something, I'm on the other party. I'm thinking that you should come up with new techniques. You should not rather rely on only attention and then keep on increasing the parameters, keep on increasing data and feed them, and you magically think that they'll be able to probably, and many people do think that this is right now, if you see these language models, this is their limit. So above that they cannot do, and you have to come up with the new techniques so as to incorporate with these things. So I am okay with that if people are saying that there will be some new techniques, some new methods or new architectures which probably will take us towards reasoning or towards planning, towards these things. But if you right now tell me that these language models, if given more data and more parameters, will be able to achieve that, so I would quietly disagree probably. Any questions? I think Muzaffar, you had a question.
यस सर,
Yes.
अगर हम कोई भी जैसे कि प्रॉम्प्ट्स हम यूजुअली देते हैं, तो अगर हम कंटिन्यूअसली 6-7 प्रॉम्प्ट्स देंगे, तो जो मैंने पहला वाला प्रॉम्प्ट दिया तो उसकी मेमोरी इसके पास नहीं होगी, राइट सर?
It depends on the context. इसके पास कितना context window है. So if context window is 1 million tokens, बहुत 1 million is huge thing. Okay, अगर तो बहुत लंबी कन्वर्सेशन कर रहे हो ना, let's suppose you are exceeding the context, तो it will miss the context. जो पीछे बात किया था, it will have no idea about that. Okay, but you should see the context length. किसका context length कितना है? How much is the context length? And after that, if you exceed that context length, so what will happen is it won't know what came before that. So it will generate. It is basically sliding window sort of thing. So let's suppose I'll restrict. Let's suppose context window length is 10. So what will happen is, so A, B, C, D, something like this. So after this, let's suppose till here it was 10 now. Okay, once it came to the 11th token, so it will shift this. It will now take this much as context. Once you again generate, it will take this much as context. Okay, it will keep on forgetting what was previously, what was not, what was basically in the context, but now its context length was that was the cap. Its context was 10, so it will keep on sliding. Okay, it won't take these two tokens into consideration now. So after that, it will keep on moving that. These are called as long range dependencies, which probably because they came up after RNNs. RNNs have this problem of long range dependencies. That's why now they have at least 1 million is very easy. People are now giving a lot of tokens, and I don't know what's the current state of the art. You might just search the internet and ask it what's the largest context length that a language model supports. Okay, and it is in millions, easily in millions. Okay, but if you exceed that, so the theory and the practice says that it won't remember what you said before that, and it won't generate, it won't take basically those things into account while generating the next token. Okay, is it clear?
यस सर, सेकंड क्वेश्चन इज सर, जो ये जनरेटेड टेक्स्ट हम ले रहे हैं एलएलएम से,
राइट,
तो फिर जो हम ह्यूमन जनरेट करते हैं बाय हैंड या कुछ लिखते हैं बाय आवर थिंकिंग, तो फिर उसमें उतनी डिफरेंस नहीं होगी सर? अगर मतलब वो जो जनरेटेड एलएलएम से अगर उसकी वो फैक्चुअल इंफॉर्मेशन है, तो फिर हम नहीं कर पाएंगे ना उसमें डिस्टिंग्विश कौन humanly generated है कौन?
Very hard. Yes, it is very hard now, and people are trying to come up with tools. Yes, and there is a good thing. So if you know, there is a facility where people are keeping all these crops, वो सब चीजें. So they are thinking that if this whole civilization is destructed, so we should somewhere have this thing so that they can start the civilization. And there is that exactly, don't know the name, I forgot the name. So there is that thing where they keep these different types of crop seeds and sort of things, and they preserve them so that if let's suppose some catastrophe happened, everything got lost, and only that facility is there, and they are making the facility such that it would not be destructed by that, and after that humans are there, they should be able, from there they should take these seeds and sort of thing, they should start the thing again. So same should be done with the internet now till let's suppose large language models were there, so we had all the data was from the humans, at least more than 95% data was from humans, and now your models were trained by using this data. Okay, once they were trained using this data, what happened is, and now you will mix this data from the humans and from this, and now you don't actually, internet should be a snapshot. There should be a snapshot of the internet kept Once these models came and people started training them, now each of the message, emails, they are basically written by these, and Copilot and code is even written. So now we have what's called the self-referential problem. So a student can be as good as a teacher if the student doesn't have the intelligence. The same thing happens with the GPT because they have this self-referential problem. So whatever humans did, they can do it best up to only that level. Okay, LLM cannot be better than the best speaker in the world. It cannot be better. It cannot be better than the best writer in the world. Why? Because if that is the best writer, that is the cap. Because it's trained on human data and it tried to learn the human distribution. Okay, as I said, I usually say this, that it is trying to simulate intelligence. It is not being intelligent. So if it was intelligent, if you gave it things till relativity, till gravitation, so all the physics was given to it till gravitation. If it was able to predict relativity, okay, if it was able to come up with these concepts, then it was intelligent. Now, why I said it's just simulation. It is not intelligent behavior. It is simulation. So what it tries to do, whatever knowledge it gets, it will generate just hocus pocus and mixture of those things. And it might look intelligent. It might look like that because, as I said, it's very hard for a human to differentiate what is intelligent and what is not. Okay, and because it is trying, it mimicking those things. But if you see real intelligence should lie here. So if you give it, suppose knowledge of physics till gravitation, it should come up with the relativity. But it does not do that. Okay, so I hope that you got this notion at least, that it is not being intelligent, it is simulating intelligence. Okay, so now I believe that internet should be snapshotted, and I think that people will have the data set why it will be pure for humans. So because language model will be as good as human, the best human. Yeah, I think Fahad has a question.
Sir, as you have said multiple times previously that the top scientists are working on solving this problem of intelligence. Like if large language models are just trying to simulate intelligence, then how can they expect them to be self-aware and intelligent?
Not with, that's what I said. And if you just heard me carefully a couple of minutes ago, I was saying that the techniques are used in large language models, they have this limitation. But if you have to come up with something, you have to come up with new techniques. So if you have this concept of consciousness, if you want to come to close to AGI and things like that, you should come up with new techniques. Now the problem, many other people are working in just increasing the parameters and using the same techniques. But if they come up with new techniques, then I have no problem of thinking this, yes, they can come closer. But by using this, what they are saying is, many other people, they are saying if we increase the parameters and then use the same architecture, probably it will learn to reason. But that's not the case. If you come up with new techniques, then maybe. And then there is maybe. Yes. You have a follow-up question.
Sir, I want to ask: is intelligence learned or it is present inside us right from when we are born? Like
intelligence is that's the issue. Intelligence is not learned. So every human is intelligent. Okay, now there will be levels of intelligence. Okay, and it is very hard to define intelligence altogether. Okay, that's why we are struggling to tell. If there was a specific definition of what intelligence is, we have directly said that ChatGPT or these LLMs, they are not intelligent, they are just simulating intelligence, because there is no definition. And even that's the problem we are facing in education system also. So should we now ask people to solve as many problems? Because the point is, now you have coaching centers, and this is very unfortunate to say that these people are more trained, they are like GPT, they are simulating, they are not being intelligent. And I have seen people, I'll just give an instance. I have seen, I have studied among these rankers, IIT JEE rankers. So what happened is, I'll tell you an example from a physics guy. So, and most of you will laugh at this. The physics guy, so if you see this was a pressure cooker. Okay, and we're cooking something, and now you know that pressure cooker, once it boils, it has a lot of pressure inside, and if you try to open it and it somehow you opened it, because of the pressure, it will go upwards and there will be a huge blast and it will create a mess. So that guy knew how to solve the equations, and because it was hard coded in him. So he tried to open the pressure cooker, and I was asking him, hey man, you are a physics major and that too physics topper. So don't you think that if you open this, that it will blast? Okay, that is where the intelligence doesn't kick in, because he was so trained in formal thinking. He was so trained in, give me an equation and this is how it should be solved and this is how it can be done. Okay, that's the problem with these training programs. So if you take these people and then ask them to do training for IIT, let's suppose for 3 years, 3, 4, 5 years, and then they basically see the patterns. Usually what I say is, it is not difficult to do an assignment. The difficult is come with an assignment, come with new questions. Okay, there are different websites which have all these questions, previous questions. Now the actual task is done by the professor, who comes up with new questions, which was not previously asked, which was not previously in any pattern. Okay, if somebody can do this, so that is one level of intelligence, because he has to understand every material. Okay, that's why doing research is hard. Why? Because you have to first identify the problem itself. You don't know the problem. Okay, and you read a lot of things and you see a problem first. And coming up with this good problem is a huge task. Sometimes it takes years to do this. And we have PhD students here and they know. Muzaffar will tell you how hard it is to come with actual problems. This is the problem and this is we want to solve. Okay, and then people take any problem and they say, okay, I want to do this thing, so it is better. So coming up with a good problem and coming up with, let's suppose if you have knowledge of something and coming up with good questions about that is actually a hard task. So that is an intelligent behavior. But this is at a vague level, but I can't define what intelligence is. If I define them, then problem solved. I wouldn't have concluded. Yes, Muzaffar wanted to say something.
सर रिसेंटली मैंने पेपर एक देखा था, उसमें उन्होंने यही किया था कि उसमें उन्होंने फ्रॉम ह्यूमंस को बोला था कि कुछ उन्होंने असाइनमेंट्स दिए थे कि यही आइडिया जनरेशन पे रिसर्च आइडिया
Right.
फिर उन्होंने फिर चैट जीपीटी से फिर उन्होंने बोला कि ज्यादा हमें अच्छे जो चैट जीपीटी ने वही ज्यादा नॉवल लगे एज कंपेयर टू ह्यूमंस.
I told you that idea generation is good for that, because idea generation it has a lot of knowledge about the world. It has all these mathematics, physics. So idea generation अच्छा है. But now you have to validate, are these ideas good? You have to validate that. Okay, but if let's suppose if you ask it कि this is the physics problem, okay, इसमें इतना knowledge है. Now because it knows this stuff and it can come up with the ideas. But let's suppose if it has to find an actual novel thing, it won't be able to do that. Okay, but if you now have a human, let's suppose take Einstein. Einstein studied about light. Here the information, give the same information to GPT. This is the property of light. This is the material about light. Okay, what can you say about light? It will say nothing. It will basically say something, but they won't have the content value. They have style value. But if you give a human, because human has the thinking ability to come up with new things, so they'll come up with these new things. So they'll come up with, because they are not simulating intelligence, they are actually being intelligent. But as I said, idea generation in the longer context can be seen. And yes, and even those ideas might be written by somebody on the internet, because it has now capabilities of this. You think like this, you are a human over here. Okay, how many connections you have? Probably you are less connected. You may ask me, you may ask some friends. Okay, what? But ChatGPT has the access to the entire internet's knowledge. Whatever there was, it basically means it can contact 8 billion people. Okay, this is not a fair competition at all. If you ask generate ideas and generate ideas to humans, because humans are restricted by whatever their knowledge is. But if you give them time, let's suppose you give ChatGPT time and you give humans 1 month, then humans will come up with something novel which basically they did not verify from somewhere, but it was just out of thinking what they thought. Okay, but if you give the ChatGPT, you will see that ChatGPT did give some idea generations, but they were not as novel as humans did it, because it just tried to just simulate whatever was there, whatever was on the web, and it just tried to, from the context, try to generate whatever the knowledge it had, and it tried to generate those tokens, as I said. But humans actually having intelligence will keep on thinking about it, will keep on thinking. But that's the problem with these language models. You ask them, they stop. You train them, they stop. But let's suppose I am speaking to you right now, because humans never shut down till death. Okay, even while you are sleeping, you are still thinking about something, and God knows what you are thinking. God knows how your thoughts are processing. But these models, let's suppose if you train them and if you deploy them in a system, and if you don't retrain them continuously, they don't do anything on their own. But humans, if you see, right now we are talking about things. So what will happen after a while is maybe subconsciously you have your own brain, and in the dreams also you will think about this, and there is a complex process going on. And that is what seems as intelligent behavior to me. That's what leads to intelligent behavior. But I don't think these LLMs do that. Okay, and they don't process the information like that. And then there should be a mechanism of doing that. Now people are doing reinforcement learning, human feedback, and they are keeping these machines content and whatever they generate, and they should learn from it. And again, it will be a self-referential problem, because it does not have that. I think Asif has a question. Did I answer your question, Muzaffar?
Yes, sir. It can give you a problem, but it cannot tell you the feasibility of the problem.
Yes, yeah, that's a good point. So let's suppose if you ask it to generate a beautiful house, it will generate a beautiful house, but that house, because of structural problems, won't ever exist. Okay, it will, let's suppose, make a Taj Mahal. It will say you can put tomb over here, you can put tomb over here, and then you can color this and that. But that Taj Mahal you won't be able to make. Why? Because it's not feasible in the real world. You cannot, because it did no calculation. But if you ask humans will think, they have constraint. Okay, if I put a structure, maybe the structure is not feasible at all. So it may generate things which are not feasible, which are not realistic, and they might look good. That's the issue. They might look good, and people might get convinced. Oh, it looks good. Should I try it with this? No, because why? It generated, because the way it was trained. It will generate something very, very good looking, but that won't be the reality. Yes, Asif had a question. Yes.
Sir, sir, ये लेक्चर सुन के लग रहा है we are superior.
You are? I didn't get
We
you.
are superior.
Humans are way superior. Way superior. Yes, Asif.
I had a question how these models are continuously trained. Like sometimes there are new research paper or new research coming up. How the version control or how these models are continuously trained.
So yes, I'll tell you the things like what happens is usually when transformers came, they do what's called as architectural change. Okay, architectural changes are done. So they do different. Let's suppose if you see GPT architecture and if you see Llama architecture, so both of them I would love to discuss with you once we go to language modeling part. So you will see that the framework they're designed on is pretty much similar, but the internals are quite different. Let's suppose this also used embeddings. It used embeddings, okay, and this uses something called as it uses positional embeddings. This uses something called as rotational embeddings. Okay, here also it uses attention. This is called as self attention. Here it uses something called as attention with cache, group multi-query attention. Okay, if you see individual parts, you will see corresponding thing there, but they have complicated a bit. And if you see here, they use the simple norm layer, and here they use something called as RMS norm. That's one aspect. So they do some architectural change and they replace the things with this. Okay, and other thing is that they come up with some novel algorithms to infuse. Let's suppose they'll introduce some other things in here. They'll introduce some other algorithms. Okay, that's one dimension. The one dimension is architectural change. Then you can have some other algorithm. You can come up with new techniques also. Come up with new techniques and do that. And maybe there are a lot of improvements. You can change the way it trains. You can change it the way it infers. You can try to come up with a lot of mumbo and jumbo. And let's suppose then there are two ways to think about it. One thing is from an experiment point of view. Experimentalist will think that we'll add on these things and we'll experiment. And from a theorist point of view, he'll see, okay, let me go with the theory. So if I do this, and what will happen to this? And he'll try to first understand it from theoretical perspective and then try to do it. Now that AI has become like this, it has become like marketing. Very sorry to say this, but it has become like that. If you should be the first person to get it in the market. Rather, science should be like this. Doesn't matter that if somebody else published it. If I am not convinced that this will give something, it should not be published at all. But now people are in the race. Whatever they find, they do publish it. Okay, but actually it should have been verified. And now the problem is there. So somebody does a research and they just found one example that it is doing something like this, and they publish it. And people try to pick up that research and they cite it, and it becomes a whole line. And someday some guy claims that the root thing was wrong. Okay, this is not how it does. The research goes down to the gutters. That's how it is happening right now. Why? Because of the funds associated with it, because of the grants, and because of this AI hype. People want to get the papers, accept this and that. Because if you write something about LLMs, there is a high chance that people will accept it. Okay, but this is how the research basically should be done. So it usually should have some architectural change, and they should have different mechanism of training also, and maybe within each component can be modified. So you can think of modification of each component. Maybe all together you can scrap the whole architecture of this. You can come up with new things altogether. Okay, that's how they are doing it now. If you see these, the major portion that is happening right now, they are increasing data and increasing number of parameters and doing a lot of computation. So that's why Sam Altman recently asked some $7 trillion. So it's not even economy of many countries is less than that. Okay, so he was asking because why? Because they want to get bigger GPUs, because they are thinking if you feed more data to it and with these architectures and everything, and we can come up with this. But if you see humans are intact because they want to mimic human brain. Okay, I just tried to give you the sort of bird's eye view. What are the different things that people do? They do architecture change, they do change in training, and they try to come up with new algorithms. They try to come up with new data. And the best part is for me is they come up with new techniques. If you come up with new tech, let's suppose attention was a technique that Transform introduced. So whatever you see language models performing, the technique was introduced in 2017. Okay, that's the paper is titled that attention is all that you need. Attention is all that you need. And it was published by Google. Okay, and then OpenAI basically used it. And the OpenAI was funded by Microsoft, and basically the rivals did it. So they published research and they did not know how much amazing this could be. So OpenAI used in their GPTs, and then Microsoft is basically partially funding OpenAI, and they made these. And even Satya said that we made Google dance because Google had a project running. So they had something called as Lambda. Okay, and they were not anticipating that somebody else would use these techniques and come up with the model first. So OpenAI basically released, and there was no prior notice. Google did not know that people are doing this, and then in that wave they released that Bard, and it was a disaster. Okay, and because they were not ready to, because they had a plan. Usually companies do have a plan. Okay, in 1 year we'll do this, in 2 years we'll do this, in 3 years they had a plan. But once this OpenAI released ChatGPT, and these people, Google people, were forced, and there was a code red alert that time. Every of my professor who was working in Google, because I was at that time doing masters, so, and they were asked to come to the office, okay, because they wanted to see, because they had a threat, because if GPT was performing and they didn't know what happened, people were coming with Perplexity AI and this, and they were thinking, because our main stream of income is search, so if somehow GPT and these language models can be used for search, then our business model is gone. And they had the code alert, and you can see the beauty of the research. So if you do research on this front, because they come up with new technique, I was talking about techniques, so they came up with technique of attention, okay, and after that GPT came with just one concept of attention, or from the transformers they came up with these large language models. So if you come up with good concepts, good sort of things that can be used somewhere else, and that's the way research should be conducted, not that you just got something and you want to publish it. Okay, you can do organic change, and you can learn about a lot of stuff, and then come up with new techniques so as to revolutionize the field, rather than just seeing what is it taking, and if you just get a result, and maybe we'll get some grants, we'll get a research accepted. That's a very wrong way to look at it. I think Fahad has a question. Yes, Fahad.
Sir, I wanted to ask this question a long time ago, like in this lecture. I wanted to ask that is intelligence just the way, the structure of our brain, the structure of our neurons, and how they are arranged, their arrangement? Is it what constitutes intelligence, or what? And if it is, then why can't we replicate it?
Oh, very hard question. Because we don't know about brain. We don't know anything. We know very little about brain. And that's why we're trying to mimic. So whatever we're doing in deep learning, whatever we're trying to do in this recurrent neural networks, feed for neural, they're all inspired from brain. Okay, but if you ask me, we have not understood the brain fully. We have understood very minuscule parts of it. That's why people are interested in biology, neuroscience. They want to see different aspects, and they want to do it computationally. Can we perform the computations on this? So if you see, all of these things are inspired from the brain. But as humans, the limitation is that we don't understand the brain itself, and there is a huge research going on the brain, on brain of rodents and different things. So what constitutes intelligence, how these neurons are connected, and that's what led to the curiosity. And after that, deep learning field came into existence, and it took off recently. By recently, I mean in I think 2006 onwards, it took off. Okay, and after 2012, though, it became uncontrollable, and now we are still in that bubble where people are learning about these things. If many of the and people do contest against this Nobel Prize given to the AI people, so they are saying that they are stopping this frontier research. All of this happened because of frontier research. So by frontier research, I mean you should not see just applications. Research will find some applications, something will not. But if you give a prize, Nobel Prize to the AI for chemistry, you gave it to the Baker's lab, and for physics, you gave it to the Hinton and Hopfield. Hinton came up with the backpropagation, and Hopfield came with what's called as Hopfield networks. And they have their links in the computational aspect. They were computer scientists, and now people are saying if you give prize, you are sending a wrong message. The message is that you should pursue these fields where there is money, because of capitalist society, and you should not pursue the frontier research. The frontier research is rather that where you just are curious and you want to discover it because you have curiosity, not that there is some implication, direct implication. It's a good thing to find applications, but the frontier research is not necessary that you should find it. So if you see mathematics, and mathematics is just a tool, then people should not study mathematics, because if you just ask, okay, where is abstract algebra, probably I won't know where it will get used, and maybe someday somebody will use it. But this should not be the case that people will just give the prizes and fund the things that just seem practical to them. Okay, and regarding the human brain, that's why the people are thinking, okay, will they stop the research funding in this also? So if some people want to study about brain, because it does not probably see the direct implications in the real world, so will it be the case that they'll stop the frontier research? And should not be the case. So short answer is that we know very little about the brains, and the more we know, and probably more techniques will develop. And where intelligence comes from, nobody knows. It has some links with consciousness, and what consciousness is, we don't know. And to quote the scripture, and it is said that we know very little about the Ruh. Any other questions? Anwar has not asked any question. Yes.
No, I don't have any question.
Okay, at least did you at least got some perspective about the generative AI and in particular the language models? At least some sort of okay, what you should expect from these models.
Yes.
Okay, you should not now if somebody puts a LinkedIn post, hey, I asked ChatGPT this, you should laugh at that post. So, but I'm saying what we should talk about. So yes, actually I can stop the recording now.